Hello everyone, in continuation with the previous video of solving to given question or proving the given question by using trigonometric identities, now we are going to look into more difficult and those questions wherein we'll be using two or more than two identities to solve the given question. So as you can see here, the first question, sin a plus cos a the whole square and plus cos a plus sec a the whole square. So I think opening the right hand side is not going to give us two separate brackets of binomial squares, right? So we'll go with the left hand side. So the left hand side, sin a plus cosec a the whole square plus cos a sec a the whole square. So here we'll be applying the algebraic identity a plus b whole square. So a in the first bracket is sin a and b is cosec a. Whereas in the second bracket a is cos a and b is sec a. So let's apply it. A square plus 2ab plus b square. Right? Similarly, the right hand side, sorry, the second one. So cos square a plus 2 cos a sec a plus sec square a. Now what I'm going to do is I'm going to place both the 2's together, cos square and sin square together and cosec square and sec square together. Okay. So I'm going to just rearrange them. So it will be sin square a plus cos square a plus 2 sin a cosec a plus 2 cos a sec a, right? Plus cosec square a plus sec square a. First of all, I'm going to apply the trigonometric ratio rule. That is, the sine and cosec are opposite to each other. Same way, cos and sec are opposite to each other. So when cosec and sine are multiplied together, that will give us 1. Same way, cos and sec are multiplied together, that will give me 1. The next one I'm going to apply is the trigonometric identity for sine square a plus cos square a and cosec square a separately, sec square a separately. So first I'll do this trigonometric ratio rule. Okay, so I'll keep the sine square a as such, cos square a, and I'm just making a group because I'm going to apply the trigonometric rule, that is the identity, plus 2 plus 2 plus cosec square a plus sine square a. Right? Now, sine square a plus cos square a, the identity says 1 plus 2 plus 2 plus cosec square a is cot square a plus 1. And sorry, that was a sec square a. Mistake. Yeah. And sec square a is tan square a plus 1. So you can see here 1 plus 2 plus 2 is 5, 5 plus 1 is 6, 6 plus 1 is 7. So we are getting 7 plus cos square a plus tan square a, which is our RHS. And we have proved it. Correct? So what did I do? I've applied the algebraic identity a square plus 2ab plus b square as the first step. The second step, I've just rearranged based on the trigonometric ratios, that is sin a cosec a and cos a sec a together. And then the sine square a plus cos square a has a trigonometric identity. Similarly, cosec square a and sec square a, I've just placed it at the end. So for sine square a plus cos square a, it's 1. Sin a into cosec a is going to be 1. So 2 into 1 is 2. Cos a into sec a is going to be again 1 because they are multiplicative inverse. So 2 into 1 is 2. Cosec square a, I've changed cot square a plus 1. And sec square a, tan square a plus 1. So 1 plus 2 plus 1 plus 1 plus 1 is going to give us a 7 cot square a plus tan square a. Clear? Next. Now I'm going to change and apply the trigonometric ratio for sec a. Here also sec a and tan a. And we have to do the LHS because RHS is only 1. We have no other option. So sec a 1 minus tan a sec a plus tan a. So sec a will be 1 upon cos a. 1 minus sin a as the numerator, because that whatever fraction I'm going to get, I'll be multiplying this to that to the numerator. 1 upon cos a plus sin a upon cos a. So if you can see here, we have cos A. Just here I need to first do the common denominator. So here 1 into 1 minus sin A will be 1 minus sin A divide by cos A, correct? And in the next bracket I can say 1 plus sin A divide by cos A, right? So the denominators get multiplied and the numerators get multiplied. So I'll get 1 minus sin A into 1 plus sin A divide by cos into cos, that is cos square A, correct? Now 1 minus sin A into 1 plus sin A is A minus B into A plus B, which is A square minus B square. So 1 minus sin square A divide by cos square A. And what is 1 minus sin square A as per trigonometric identity? It is cos square A. So cos square A divide by cos square A, that is equals to 1, which is our RHS. Okay. So I just simply did the conversion of the trigonometric ratio sec A and tan A, which is converted into sin and cos, and then took the common denominators, multiplied it, and applied the trigonometric ratio, identity. Next. Now what I'm going to do in this one is, as I can see in the numerator, I can take sine as a common factor. Similarly, cos as a common factor. So I'm going to start with that. Again, there is no use of taking the RHS because RHS is having only tan theta and we cannot do anything with the tan theta. There's no rule for that. Okay, so let's take the sine as the common factor in the numerator. So when I take sine as a common factor, I'll get 1 minus 2 sine square theta. And when I'm taking cos as the common factor in the denominator, I'll get 2 cos square theta minus 1. Now I'm going to write this 2 sine square theta as minus sine square theta minus sine square theta. And 2 cos square theta, I'm going to write it as cos square theta plus cos square theta, as a plus a is 2a. So I have 2a, so I'm just opening it up as a plus a. Same rule I'm applying here. I'm having 2 sine square. So I'm just writing sine square theta minus sine square theta. I have not changed anything in the question, right? Okay. And similarly in the denominator also I'm going to open that. Now what I'm going to do, I'm going to write the identity for 1. What do I mean by for 1? Sine square theta plus cos square theta equals to 1. That I'm going to apply in the numerator and the denominator both. So both the places wherever I have 1, I'm going to put sine square theta plus cos square theta. So let's write it down. Sine theta will be common. I have a 1, so it's sine square theta plus cos square theta minus sine square theta minus sine square theta, right? Then my denominator, cos theta. I have cos square theta plus cos square theta minus 1. So sine square theta plus cos square theta both will have a minus sign. So minus sine square minus cos square, right? Now in the numerator, the sine square and sine square will cancel off. Similarly, one cos in the denominator gets cancelled off. So you will get sine theta, and the bracket you have cos square theta minus sine square theta, right? And in the denominator, you have cos theta, cos square theta minus sine square theta. So we got the the both brackets are equal, so cancel it off, and that is equal to tan theta equals to RHS. So what did I do? I have taken the sine as common in the numerator and cos as common in the denominator. Then I've just written 2 sine square theta as sine square minus sine square theta minus sine square theta, and plus 2 cos square theta I've written as cos square theta plus cos square theta. Then in place of 1, what I have written? Sine square theta plus cos square theta for the numerator. Because in the denominator it's minus 1, therefore I have written minus sine square theta minus cos square theta. So in the numerator, that 1 sine square plus and minus gets cancelled, and in the denominator cos square plus and minus gets cancelled. What remains is sine theta upon cos theta bracket cos square theta minus sine square theta upon cos square theta minus sine square theta. Common factors gets cancelled off and you get a tan, right? Let's take the next. Now again, we'll have to do the LHS. Sometimes in trigonometric ratios, identities, when we start proving it, we get stuck at one point. or we are unable to get to the right hand side, from the left to the right hand side. So in that case, what we do, we solve the LHS, we solve the right hand side, both of them will be equal to a common concept, a common term. They come out to be common. Then we say they are equal. Like in this case, I'm going to do it. Okay. So cosec A minus sine A, and that is acceptable in trigonometric identity proofs. Okay. So let's write the cosec A as 1 upon sine A minus sine A. Okay. And sec A, you'll write 1 upon cos A minus cos A. So we need to take the LCM, right? So when you take the LCM, it's 1 minus sine square A upon sine A. And in the next bracket, if I take LCM, it's 1 minus cos square A upon cos A, right? 1 minus sine square A is, yes, it's a cos square A. So I'll get a cos square A upon sine A into 1 minus cos square A is sine square A upon cos A. Correct? So one sine goes off and one cos goes off. So I'm getting cos A into sine A. And I'm stuck there. So I'm leaving the LHS like that. Now I'm going to try the RHS. And let's see whether I'm getting RHS as cos A sine A. So 1 upon tan A plus cot A. Now we need to change it into sine and cos. There's no other way out. So let's do. So sine A is tan A is sine A upon cos A plus cot A is cos A upon sine A. So we need to take the LCM for the denominator. The numerator is still 1 now. So the denominator will be sine A cos A. And what happens? Sine square A plus cos square A. How? This sine A will get multiplied, so it becomes sine square A. Cos A will multiply, so it becomes cos square A, right? So are we getting, sorry for the interruption. Now are we getting 1 upon cos A sine A? 1 for the numerator. Sine square A plus cos square A is 1 divided by sine A cos A, right? So this will go up and get multiplied to the numerator. So the answer we are getting here is sine A cos A. So are we getting RHS equals to LHS equal to sine A cos A? So it's proved. Okay, right? Clear? Let's take the next one. Now, oh, it's printing mistake, 4. Okay, let's start the LHS. Clearly, I can take sec square A as common. So what's left out is sec square A minus 1. Right? Now, what is sec square A? And sec square A minus 1. We have to apply both the identities. Sec square A is tan square A plus 1. Right? Again, for this one, I'm going to put tan square A plus 1. So wherever I'm having sec square A, I'm putting tan square A plus 1. Right? Clear? So this will be tan square A plus 1. And the next bracket will become just tan square A. Why? Because the 1 and the 1 are getting cancelled off. Now you multiply the tan square A with tan square A and tan square A with 1. Means you open it up. So you will get tan raised to 4A plus tan square A. And that's your RHS. What did I do? I've taken the sec square A common. Then I've applied identity for sec square A as tan square A plus 1 for this one and for this. Both of them I've put tan square A plus 1, tan square A plus 1. The 1 get cancelled off. Then you just open it up. You get your answer.